Okay, I think we're finally ready to go. All right, so what we'll do today is finish up some of the background. I've been giving you background on energy, what energy is, various forms of energy. We'll finish up the forms of energy here and talk about efficiencies, things like that, how it affects sort of modern day use of energy. And then we'll get into fossil fuels. I know a little about fossil fuels. You guys know a little about fossil fuels. We'll spend some time talking about that. So up to this point, we were talking about forms of energy. So we have types of energy like energy within chemical bonds, chemical energy. Typically what we do is burn things to release that energy, and we get heat energy, another type of energy. And then we have things like energy from mass, E equals mc squared, nuclear energy, kinetic energy, potential energy. I missed one or two in there, but you can look back at your notes. And we have various forms of energy. So we have a lot of different ways of potentially creating energy for our own use. Electromagnetic radiation is another form of energy, okay? And this is energy from light. Light is a form of electromagnetic radiation. You guys see just a very narrow band of all types of light. But there's light that you can't see. Like, you can't see infrared, you cannot see ultraviolet, you can't see X-rays and gamma rays, radio waves, microwaves. You have a limited range that your eye can perceive. But all of those types of energy are considered to be electromagnetic. So, again, light, some of it's visible, some of it's not. To you. Now we have animals that can see a slightly different part of the spectrum, and I have this real cool camera in my office that can see thermal energy, infrared. It can see things that you can't. Now some of this energy we use on a daily basis. We've been using this type of energy for quite some time for communications. Going back extensively into the 40s, 50s, using radio. Your cell phones now work a lot off microwave transmission. And some ingenious souls have figured out how to turn light into electricity. We talked before about how we love as humans to transform one form of energy into another. Potential into kinetic, into electric. Well, we can turn light energy into electricity with things called photovoltaic cells. That's the basis for solar energy here in the US. What we seem to be going through as a human society is we seem to be heading fast towards an era where everything is going to be powered by electricity. It's not the only thing we could be using, but we seem to understand it well. It seems to work well for us. And for all non-transportation needs, that's one of our primary energy sources. It's running all of your electronics, running lights, running heat, heating water. A lot of the stuff you do day to day is a result of humans taking various forms of energy and turning it into electricity. And we're going to be doing that more with cars, it seems. You know, for a lot of years it was, okay, what's going to be the replacement for fossil fuels? Is it going to be hydrogen? Is it going to be biofuels? What's it going to be? Well, it seems like entrepreneurs like Elon Musk, who came along and had a lot of money and said, I really believe this is going to be the future, electric cars, puts a lot of money into it, electric cars get better, more efficient, cheaper. And I don't know, I drove to work today, I saw 4 Teslas, you know, purely electric cars, beautiful cars. So is electricity the best form of energy going forward? I don't know. You could make an argument, but that's where the money is. That's where the investors are right now. So what happens with energy, and if you look back through history, this has happened with every energy source, is there seems to be a collective groupthink among humans that, oh, we're going to use coal. And then the investment money flows into coal, makes it really efficient, and then pretty soon we have these big, huge coal firing plants. And then, oh, you know, automobiles, we have this great internal combustion engine that runs really good on fossil fuels. And then people pour their money into that and that make it real efficient. Doesn't mean it's the best. It just means that's where people believe the future is and where they can make money. Now it seems to be that the future is going to be electric, at least for the foreseeable future. So our entire energy industry is now going to be based on how can we take other forms of energy, light energy, chemical energy, nuclear energy, and make electricity out of it. That's where everything's going. Looks like hydrogen, biofuels, all those things have kind of been left behind the last 3 or 4 years. When I taught this sort of course 5, 6 years ago, we were talking a lot about biofuels and hydrogen. And there was this group of people who were really pushing it. And then there's another group that was really pushing, oh, we're going towards ways of producing everything electric. And I didn't know at the time how it was going to play out. I actually thought hydrogen might be the best at the time, but it looks like electricity is going to win. Okay, we talked about this last class, and I won't ask your example since we talked about it already, but one thing we do is we want to transform various forms of energy into something that we can use. Now, light itself is great to have, but I don't know how to make my computer run on light directly. So I have to take that light, turn it into electricity. We have these great powerful tides and winds, right? But I can't hold my computer up in the wind and make it work. So we have to take the wind energy and transform it into something that's going to power something else. Wind is one of my favorite examples just because it is pretty complex in terms of all the different stages in its production. Ultimately, our winds are created by heating and cooling of air. So what heats our air? Well, the sun heats our air. So to understand this example, we get to go all the way to the sun. And the basis for how the sun works is the sun, when it first formed, was pretty much totally a big ball of hydrogen. Hydrogen is the most common element in the universe, and all this hydrogen gathered in this big ball gravitationally to form the sun. There's so much pressure in the middle of the sun that hydrogens would bump into other hydrogens with enough energy to fuse together and create a helium atom. And when that happens, you take those two hydrogens, you fuse them together, it forms helium and gives off just a tiny bit of energy. Just a little bit of that mass is consumed. E equals mc squared. And that energy comes off the sun in the form of heat and light. The sun gives off both, as you know. You can see the sun burning and you can feel its heat. Now, it's mostly the heat that warms the atmosphere, but light plays a role as well. So the heat, as we talked about, I think, the first day of class, causes atoms to vibrate more rapidly, move around more rapidly, take up more space. So the gases in our atmosphere heat up, vibrate faster, expand. That lowers the density. Bottom line is, air starts moving when it gets heated up. That's kinetic energy. So we took nuclear energy, turned it into heat energy, turned it into kinetic energy. So now we have kinetic energy moving air. Well, what we do is we stick a windmill out there. And where all those three propellers of the windmills come together, that rotates really fast. There's a bunch of magnets in there that are rotating around a whole bunch of coiled wires. What do we say happens when you take magnets and rotate it around wires? You get an electric current. And it's a lot of kinetic energy. Take a look at those big windmills that are out on the prairie right now, and you see them spinning. The length, have you seen the propellers go by on the highway on the trucks? They're about 90 feet long. So those 90-foot blades are turning, and when they really hum, they can do about a revolution a second. And if you look at the path that that is taking and do the math, the outer edge of those windmills are moving almost 300 miles an hour. Doesn't really look like it, right? You can just see them kind of going around, but they are really moving. So that's a lot of kinetic energy. So you can move big magnets around huge coils of wire and create a lot of electricity. But remember what we also said, is that at every stage of transformation, you lose a little energy to inefficiencies. Wires heat up, there's friction. Wires are not a perfect conductor. Once you create the electricity, electricity flows through wires. Well, there's resistance to flow, and resistance causes heat. Heat is then dissipated from the wires, so you lose a little electricity there. So what we do over time in order to make this process better is we try to make our turbines less frictional, so they spin easier, so you can spin them with less wind. And then we try to find materials that conduct electricity without heating up, superconductors. A superconductor is a material that will conduct electricity with essentially no loss to heat. We have great superconductors, but the state of the science right now is that to make a superconductor, it has to be ridiculously cold, 100 degrees below zero. You can make a really great superconductor at 100 degrees below zero. Not really practical for human use, but we're getting better at it. And at some point, we'll be able to develop superconducting materials that will transmit more energy and lose less of it. We'll get better at this. I was just telling my last class, that's one thing science does. Science isn't perfect. We're in this age right now where we're really polarized, especially, think of coronavirus, right? Came out a few months ago, and at first, wear a mask, don't wear a mask, wear a mask, don't wear a mask. It was all over the place. And that's what scientists do. They come up with ideas, they test them. The better ideas stand the test of time, and the bad ideas go away. Science always gets closer to the right answer. I can't recall a certain time in history where science actually got us farther away from the answer. So as time goes on, we get better at this. We get better with dealing with coronavirus. We get better with being efficient with energy. So again, this is called conservation of energy. Energy in a closed system cannot be gained or lost. So when I say energy is lost, what actually happens is a little bit of that energy, electrical energy, rather than staying electric, which is what we want, instead a little is lost to heating up wires. or fighting friction. So there's less at every step because some of it is lost to inefficiency, and almost all of this is heat. If you've ever been at a nuclear reactor, I grew up in Wisconsin, and we had several nuclear reactors, and they're always on the shoreline of something. 3 Mile Island was a big nuclear disaster here in the US about 40 years ago. And it's right on the water. All the nuclear reactors in Wisconsin, right on Lake Michigan. And the reason is that when you have a nuclear reaction, we're trying to produce electricity, but we're getting a ridiculous amount of heat and we can't figure out how to use it all. So we lose it. So we have to cool down the machinery with water. So nuclear reactors are great for producing hot water that would then turn back into the environment. So some of that energy that could go into producing electricity is lost. It heats water up, and we then pump it into rivers and lakes and streams, which isn't really good for the rivers, lakes, and streams either. So basically, these inefficiencies lessen the energy for us to do work. And as it turns out, there's a whole industry out here today that is based on making this process more efficient. And if you can figure out a way to increase energy efficiency by even a partial percent, you can be a gazillionaire. Because there's a lot of money to be made, because we have now 7.5 billion people on this planet that all want energy and want it cheap. And we're getting to the point, especially those of us who live in Colorado right now, we want to do it without carbon. We got forests burning up, and this is getting kind of ridiculous.
I was in Fort Collins last night, and it's literally snowing now.
I don't know if you guys heard, but there's now another fire. And it grew at 6,000 acres an hour yesterday. It's at 90,000 acres in a day. And it took the Cameron Peak fire 2 months to get that big. Did it in a day. Okay, let me... I got to switch computers here to do this properly, so hang on for a second. Okay, as you know, Colorado was one of the first states in the nation to legalize recreational marijuana. And it's a huge industry. It's a billion-dollar industry now in Colorado. And I have a radio clip from NPR that talks about the energy needs of our cannabis industry and how efficiency experts are coming in now to make a lot of money helping cannabis use less, the cannabis industry use less energy. So let's see if I can pull this up. Energy hungry. Okay, let me switch here. Hope this works.
Colorado is now in its third year of legal cannabis cultivation. The industry seems to be doing well, but growers also have a problem. They're getting a reputation for using a whole lot of energy. Denver officials believe cannabis accounts for between 1% and 2% of the city's total electricity use. But as KUNC's Stephanie Page Ogburn reports, that may be changing.
So you can see we're actually on day 1 in here.
The first thing you notice when Nick Heiss opens up his marijuana grow room is the light. Wow, it's really bright in here.
Yeah, it is, and you can see very orange.
Dozens of cannabis plants sit on low tables here at Denver Relief's growing facility, and there's giant light fixtures, similar to the kind used in stadium lighting, strung overhead. Heiss says that getting that lighting just right is key to being a successful grower.
It's very important. It's it's one of the things we talk about most with these artificial environments.
But while these super bright lights are great at growing high quality, high yielding cannabis, they also use a ton of electricity.
The other big consumer is the HVAC system.
Plant scientist Neil Yorio works for a lighting company called BIOS. As he explains, the energy to remove and cool the heat created by these stadium-style lights is another big cost for growers.
So those two together are 50 or 60% of your energy.
But Yorio thinks he has a solution. I met him in a smaller experimental grow room just a few steps down the hall from Denver Relief's main cultivation site. He was waving a probe over several cannabis plants.
So right now I'm measuring a light level of, right here at this particular spot, of about...
In this room, instead of blazing orange light, a soft blue-white ambiance beams down onto leafy cannabis plants.
The LED technology offers an immediate solution to one of their biggest problems, and that's the energy consumption that they're experiencing now.
If these BIOS LEDs can grow cannabis just as well as the standard high-pressure sodium lights, that could save a lot of energy. But first, Yorio has to prove they can do that. Denver Relief's Nick Heiss says in the first experiment, the aroma and flavor of the product wasn't quite right. But in a second trial, after Yorio made some tweaks to room temperature and the amount of light.
In a blind taste test, a majority of us leaned towards the flavor profile and the taste and their overall performance of the LED Gorilla Glue number 4 as opposed to the high pressure sodium Gorilla Glue number 4.
In other words, a group of testers who consume the marijuana couldn't tell the difference. That's good news if your business plan is selling growers on your energy-saving lighting system. And BIOS isn't the only company that thinks it can make money helping growers shrink their electric bill.
Hi, are you Steven? Hi, Stephanie.
Nice to meet you. Yeah.
Stephen Keene heads Cerna, a Boulder company that specializes in selling more efficient HVAC and lighting systems to growers. He says the money we're talking about, it's significant.
In a facility with approximately 250 lights, you're looking at roughly a $30,000 a month electric bill.
Keene says a lot of growers could be spending less.
You know, I go into grows and I see them wasting 50% of their energy. And I know that sounds crazy, but it's easy to prove through mathematics.
You start with, say, 5% waste from dirty reflectors in the lights, maybe another 5% from light that hits walls and floors instead of plants. Add another few percentage points lost by an inefficient cooling system.
By the time you add all that up, you know, you're wasting half your power.
In addition to his existing products, Keene's company is also developing a new type of greenhouse. He says that facility will let growers use more natural light as part of their operation. But no matter how they get that energy savings, there's one thing industry experts agree on. As the price for their product falls, cannabis growers are going to have to get more efficient. Those who don't may not be around much longer. For KUNC, I'm Stephanie Page Ogburn.
So did you catch how much per month some of the growers were spending on electricity? $30,000 a month. $360,000 a year just for energy. So if a company comes along and says, hey, I can save you half of that. I can save you $180,000 a year in your electric bills. Are you going to listen? Give them a listen? Yeah. Are you going to spend $60,000 on a new system? If you can save 180, maybe, right? So this is where I'm talking about. It's like you can potentially make a lot of money just by helping make energy more efficient. In fact, prior to the legalization of marijuana in Colorado, You know how cops used to find grow sites? They checked the electric bills. You know, people were growing it in their apartment and they'd have $400 a month electric bills. Nobody has a $400 a month electric bill in a tiny apartment unless you're growing dope in it, right? So that's how they would figure out, and that's how they'd get warrants then to go and check to see if people were growing illegally. It was all because of energy consumption. So again, it all comes back to this idea of conservation of energy. The problem with these grow facilities is they were using these sodium-based lights that would heat up a lot. So it was expensive. The heat showed that it was inefficient. And then they'd have to pay a whole bunch of extra money to air condition the room because the lights were giving off so much heat. And then by switching to these LEDs, which are far more efficient, they don't have as much heat. They don't have to pump in air conditioning. In fact, some of the places are finding that their grow rooms aren't hot enough, even with the lights on, so they have to add a little bit of heat. But it's far better than adding AC in to try to keep it cool. So again, all about just making things more efficient. So just a little more background. We talked about measuring power the other day. We used terms like horsepower or watts. We have units of energy as well. Joules are good units to use for small amounts of energy. We have the BTU, the British thermal unit. It measures heat energy. It's the amount of heat needed to raise a pound of water by a degree Fahrenheit. If you look at water heaters, a lot of them are in BTUs. Calorie. You guys heard calories, right? Calorie is a unit of measurement for energy. And actually there's two kinds of calories. There's the I like to call it the physics calorie. This is your standard calorie. It's the energy needed to raise a cubic centimeter. Cubic centimeter, think about a centimeter cube. It's also called a milliliter. So a small amount by 1 degree centigrade. Now the calories that we have in food are related to the physics calories. A food calorie is actually a kilocal, 1,000 calories. So those are terms you're likely to hear as measurements for energy. Okay, and now this last little definition right here. Have you all heard of renewable and non-renewable energy? Yeah, this refers to something really specific though. It's whether we can renew or add energy on a human time scale. You think about something like coal. Coal takes a couple million years to form naturally, okay? It's renewable on a geologic timetable. We're going to make more of it in the next million years and then more of it in the next million years. When we talk about renewable and non-renewable, we're talking about, can it be done on our time scale, human time scale? Things like coal, oil, natural gas, things that require millions of years naturally to produce, that's not going to replenish on our time scale. If we burn it all up in the next 50 years, there's not going to be any more waiting for us the next year. And sadly, what's happened to this point is that about 90% of our energy use worldwide is based on materials that aren't renewable. We're using it up and it's not being replenished. And those energy sources are coal, oil, and natural gas, or what we call the fossil fuels. And that's what we're going to spend the rest of the day talking about, and probably the next couple of classes. Okay, so any questions at this point? Yeah?
So, like, we have all these renewable energy sources that we know about, so we just use non-renewable more because it's cheaper.
Yeah, so 90% of our energy use is non-renewable oil, coal, natural gas. But we have solar and wind, and those replenish, they're constantly out there, right? We have those sources, but we're not using them. I mean, like, why would we use something that we would run out of and not use something that's around every day? One reason, and you said it, money. It's cheaper. And why is it cheaper? Because we've been doing it for over 100 years with oil, well over 100 years with coal. All the investment money has been going into that as an energy source. So they get really efficient at getting it out of the ground. Yeah, it's cheaper. Oil's cheap. Coal's cheap. Natural gas is ridiculously cheap. We have so much of it because we're good at doing it. We're good at doing it because for a couple hundred years, everybody's been investing their money into big oil companies, big coal plants. They haven't been investing their money into solar energy or wind energy. But what'll happen, it's just simple economics. It's going to happen, okay? We are using up oil, coal, and natural gas at a rate that within your lifetime, you could run out. You're never going to run out. I'm going to tell you right there. You're not going to run out of coal, oil, and natural gas for one reason. Again, money. So right now, oil, coal, natural gas is cheap. You guys keep using it because it's cheap. That dwindles the supply, right? At some point, the supply is going to get really low. What happens to the price when the supply drops, but we add billions of people? It starts going up, right? So coal, oil, and gas down here, cheap. Solar, renewables up here, not so cheap. But as we start running out of coal, oil, and natural gas, price creeps up, right? And, you know, these renewables, they might creep down a little because some people are investing in them, but not a lot. Okay, so they're still kind of expensive. But price is going to creep up. Now, if you're an investor and you see this, at some point you're going to say, do I want to keep putting my money into this industry? Because what's going to happen? It's getting more and more expensive and the profit is less and less because it's more and more expensive. Or should I put my money over here, and then once you put your money over there and they use that money to develop more technology and get more efficient, what's going to happen to the price as they get more efficient? It's going to drop. And then pretty soon everybody that was investing over here says, screw it, it's over. They put their money over here and then the price really drops. You are going to see that during your lifetime. I can pretty much guarantee it. Will it happen 5 years from now? 10 years from now? I don't know. And if you think back, most of you guys look like early 20s. So back in 2014 and 15 may have been about the time you were starting to drive. I don't even know if you guys remember what happened to gas prices back there. But we had been around $1.50, $2 per gallon. And because of things that were going on in Russia, we're going to talk about all this, and worldwide, gas suddenly jumped to $4 a gallon. You guys remember that? And I remember it well because I had this big old pickup truck that got 13 miles a gallon. And suddenly it was costing me $80 to fill the damn thing up. And it was costing me before that about 30. You know, and I'd have to fill up once a week. And $80 is different than 30 bucks, at least to me. And I sold the truck. I ended up getting a small shitty car that got really good gas mileage, and I was pissed off all the time because I hate little cars. But I drove it because of economics, you know? And that's when the Prius got really popular. People changed their behavior because that gas price spiked. And it's like, I can't afford this crap. Would people have behave the same way if gas had gone up, say, a penny a month? Nah, you just slowly adjust, right? You know, and if gas creeps up a penny a month, you know, over time, it's going to get expensive. But it doesn't play on your psyche. It's like, oh my God, I can't afford food, or I can't afford my tuition, or I can't buy a computer, or I can't make my insurance payment because I'm, spending all this in gas. So to me, it'll probably happen when there's some big world event. Could be a war, could be a massive storms hitting refinery. It could be something that causes gas to spike. And then people are like, screw it, I'm buying a Tesla. I'm going to buy a used Tesla because they've now been on the market 10 years and there's a bunch of used ones out there that I can afford. It probably takes something like that, but it's going to happen. Will it happen next year? I don't know. That's the big guess, But as it stands right now, oil, coal, natural gas, they're still cheaper. I don't know for how long. I hope we switch really fast. Because, we've had poor forest management. That's put a lot of fuel in the forest, but climate change has made that fuel so dry that we're getting fires that have spread like none other in history. And I'm tired of this stuff. And my wife's family owns an oil company. So every month we walk out to the mailbox and get checks from the oil company. We don't do any work for it. And it goes into our bank account. And it's all your money. And it's wonderful. I gotta say, having an oil company in the family is a really great thing. But I would love to see it go away. Because it's kind of a sick amount of money and I don't need it. And it's really hurting the rest of the world, I think. So I'm happy with my little computer. I don't need $1 million car. All right, any other questions? All right.